Our learning target for this video is students will be able to identify and classify basic types of individual angles. So we'll be looking at acute, right, obtuse, and straight angles. This should be review from your middle school days, maybe even in some elementary school days. But I just want to go over the building blocks of angles and make sure we understand angles before we start working with them in our class. So we're going to start with a point. A point has no size or shape, just a position on a coordinate grid, or it could be in three-dimensional space as well. And we have M here. It's just point M. A line segment is a portion of a line that has two endpoints. So in the example up here, AB, segment AB is our line segment. Okay, we see these arrowheads going on and on. They do not end. So that is not a line segment. That would be a line. So from A to B is the segment. A ray is a portion of a line which has one endpoint and extends forever in one direction, maintaining that same slope, or it's a constant rate of change, like you have in your line, but it's just starting at one endpoint and going in one direction only. A line is a straight path, has a constant rate of change or slope. It has no beginning or end. It goes on in both directions forever. So please note up here the notation we use. So for point, we'll just name the point, point M. Line segment, we'll write AB, and it has its hat there is just a segment above it, right? So that's the notation for segment AB. Ray, it's kind of hard to see on this, but it looks like a line segment, but one end there should be a little bit of an arrowhead like that. Well, not the best. And then the last one, the line, there's an arrowhead at both ends. So that's line XY. So you can use that notation, or you can read that notation in our class. All right, what do we call this? What would be the official name? So this would be ray ST. So you could write it this way. You typed it in, you probably had to say ray ST, but that would be ray ST. What do we call this? So this is a line segment. You can see the points K and J are the endpoints of the segment. So that's going to be segment JK. You could call it segment KJ as well, but it would just look like this with the hat, like that. So segment JK. What do we call this? All right, this is a line. You see the arrowheads at both ends. It goes on forever. So it's line CD. Notation-wise, would look like this. Arrowhead there on top of the C and the D. So I want you to understand that an angle consists of two different rays with the same endpoint. So in this example, we have ray BA here, this ray right here, going on forever. And then we have ray BC going this direction forever. Sometimes when you see pictures of rays, they don't always show it as a ray, or angles, I should say. They don't always show a ray. It could look like a segment. It could be, could be lines that intersect, and we're only talking about part of it. But for the formal definition of an angle, we're talking about two rays that go on forever with a common endpoint or starting point, if you will. So B is that common endpoint, and we call that the vertex. So that is the vertex of the angle. And the two sides are always going to be officially rays, even if it doesn't look like a ray on the picture that you get for the angle. So we have three different ways we can name angles. So you can just name it by the vertex. So we could just call this angle B, and that works if this angle is clearly associated with this demonstration here. It's just one angle. But if you have multiple angles coming off of point B, you can't use the one-letter method. Another way, the classic way to name this is using the three-letter method. So you pick a point on one of the rays, you pick the vertex point, and then you pick a point on the other ray. So we could name this angle A, B, C, We could also name it angle CBA. Doesn't matter which direction you go. You cannot start with B when you name it. The B has to be in the middle because that's the vertex point. So the three-letter method, the only key characteristic is the vertex must always be the middle letter. All right, and this works when we have multiple angles associated with the vertex B. And we'll look at that situation here shortly. And then finally, sometimes they have a number in here, not necessarily the degrees of the angle, just a number. If the number's in here, you can just name this angle 1. So that'd be another way we can name this angle. All right, here's a classic example where I cannot name this one of these angles here by angle X. Because if I name it by angle X, which angle am I talking about? Right? Am I talking about this top angle here? Am I talking about this bottom angle? Am I talking about this whole angle? If I just say angle X, it doesn't tell us. So I'd like you to name all the angles that you see here using the three-letter method. Okay, so I see three angles here. I see angle W, X, Y. That's this angle right there. Let's change colors here. I see angle Y, X, Z. That would be this angle right here. And I see another angle. If I use this entire angle there, right, that's going to be angle W, X, Z. So those are three angles I hope you wrote down. Now, you went the other way with them. If you said YXW, that's fine. If you said ZXW, that's fine. If you said ZXY, that's fine. But those are the three angles that you should have wrote down. So back in the day, you may have measured some angles using a protractor, and it gives us the approximate measure of the angles. Angles are always measured in degrees. Here's some words. We say the measure of angle WXZ is 32 degrees. So we use a little zero above the number to show degrees. And this, when you put an M in front of it, that means the measure of angle WXY, or sorry, WXZ equals 32 degrees. All right, so there's the words, and this is the symbol right here, just a little M in front of the angle symbol. All right. So here's an example of actually measuring the angle with the protractor. So you have to line up the protractor. This line has to be on top of one of the rays with the center point here on the vertex. And then you look at your other ray and see where it crosses. Now you see two numbers here, right? You see 40 and you see 140. Well, how do you know which one it is? Well, this angle is going to be greater than 90 degrees, so we know it's the larger angle. It's the 140. And we'll be talking about classifying these angles. This is what's called an obtuse angle. So we're going to use the larger number. If I was measuring one that had the same ray here, but the other ray was here, right? If I was measuring this angle here, then see how that angle is less than 90 degrees? So then I would use the top number, the smaller number. This would be 40 degrees. So it's all on the size of the angle, which one you read on the protractor. So we have four main classifications for angles. Any angle that is less than 90 degrees and greater than 0 degrees. You can't have an angle at 0 degrees. It won't be an angle. So it has to be greater than 0 degrees and less than 90. That is called an acute angle. So this is an example of an acute angle. Any angle that has an angle that's exactly 90 degrees. And oftentimes we show you that 90-degree angle using that little box. That means that's a right angle. This is called a right angle. So it's a 90-degree angle. It's called a right angle. When you have an angle that is greater than 90 degrees, so bigger than a right angle, and less than 180 degrees, which would be a straight angle like this, then that is called an obtuse angle. Obtuse. And a straight angle it looks like a straight line, right? Well, really, there's a ray going this way, and then there's a separate ray going this way, and my angle we're talking about is this. Well, it could be either side, right? But that's 180 degrees, and that's called a straight angle. All right, tell me what type of angle this is. How do you classify it? I'm hoping you told me obtuse angle. This is obtuse. How about this one? What kind of angle is this? I didn't give you the little box there, so I'm not sure that threw you off, but this is 90 degrees, so this would be a right angle. All right, classify this angle. What type of angle is it? I hope you came up with acute angle. It's less than 90 degrees. It is an acute angle. All right, last one. What do we classify this angle as? This angle is a straight angle. It's 180 degrees. That is a straight angle.